So guys, now these are the 6 basic questions in law of indices. I follow. So if we can solve these 6 basic questions, because each question is from each laws that we have in law of indices. So if we can tackle these 6 questions, we should be able to manipulate any in this initial question, any question law of indices in our WAEC, JAMB, or NECO. If we can solve these 6 questions, okay. So now the first example is that 3x raised to the power negative 2 as a solution. So the first question is 3x to the power of negative 2, y to the power of 3, z squared times 6m y to the power of negative 2x to the power of 4. Now, how do we solve this? Don't forget from our law of indices, from the law of indices that are broken down before, when we are multiplied two index like this, we are going to add their power. But here now we have a mix-up of numbers and different letters, okay? But the law still apply. What we do is that we multiply them group by group, okay? Those ones that are similar, we multiply them together, right? So we multiply the numbers and the similar letters. The reason why I'm multiplying the similar letters is because for law of indices to work, they must have the same base. We must multiply x with x. We must multiply y with y. They must have the same base, okay? So these two numbers multiplies, that's 3 times 6, right? So times this x multiplies this x, they must be the same, not x with m, x and x. So we have x to the power negative 2 plus 4 times, yes, because when you're multiplying the same index, we have their power, okay? So times y also, we have y to the power of 3 times negative 3 plus negative 2, okay? So we have 3 plus negative 2, okay, then times z squared. Do we have any z here? No, we don't. So we can just say z squared times 1. That's z squared. We don't have any letter to multiply it with. Then, are we done? No, it remains m, okay? M. So there's no m here, so just like saying m times 1, okay? So they must have the same base. Now, 3 times 6 is what? 18. Then x to the power of negative 2 plus 4. That gives us what? 2. Then y3 plus negative 2, that gives us what? 1. So that's y to the power of 1. Then times z squared times m. Okay, that's mz squared. Okay, now let's write this as a coefficient alphabetically. Okay, we love that in mathematics. So we have 18 mx squared yz squared. Simple as that. That's the solution. Applying the law of indices, the multiplication law. Now, the second question is division. 3x to the power of negative 2 yz squared divided by 6m y to the power of negative 2x to the power of 4. Now we are dividing. Don't forget also law of indices. When we divide, we're going to be subtracting their power. Those ones that have the same base, we divide them or we subtract their power. So we have 3 divided by 6. You can divide numbers by number. In case there is no number here, you just say 3 divided by 1, okay? So then times x to the power of negative 2. This time around we'll be subtracting that power, okay? Minus 4 because it's division times y to the power. It has a power of 1. It has no number here, so we can say it's a power of 1. So that was 1 minus negative 2. Then times, okay, same thing, z squared times m. We don't have anything to multiply these two. So 3 divided by 6 is 1 over 2. Please, it's not 2. 3 here 1, 3 here 2 is 1 over 2. Okay? So then we have x to the power of negative 2 minus 4. That's negative 6. Then we have y to the power of 1 minus negative 2. That gives us 1 plus 2. That gives us 3. Then z squared m. So alphabetically we have, or we can write everything as a single fraction all over 2. That's mx to the power of negative 6 y cubed z squared. Final answer for number 2. Okay, as simple as that, is not hard. Then number 3. The number 3 says 27 to the power of x minus 1, then times 27 to the power of 1 minus x. So what do we do here? Now don't forget, we have the same base and we're multiplying. So we add their what? Power, okay? So we pick 1, that's 27 to the power of x minus 1, then plus 1 minus x, okay? So we have 27 to the power of x minus 1 plus 1 minus x. There is no subtraction, so we don't have to expand the bracket, okay? So yeah, now we don't have to multiply rather. So here we have x minus x gives us 0. Okay, negative 1 plus 1, x minus x gives us 0. So we have 27 raised to the power 0. And don't forget from our 0 index, any number raised to the power 0, any non-zero number raised to the power 0 gives us what? 1. Final answer for that. Can you see the third law? Okay. Now, let's go to the next question. Number 4. Number 4 says that 2 to the power of 4 times 1 over 2 to the power of negative 1 times 2 to the power of 0. Now, we have a fraction. Now, according to that law, that whenever we have a fraction, we can express a fraction in terms of a negative what? Power. When a number has a power and is a fraction, we can convert that fraction to a negative what? Power. We're going to be using that law here, okay? And also, 2 to the power of 0 will give us 1. Are you following? Now, let's do that. So we have 2 to the power of 4 times. Now, instead of 1 over 2, we have 2 to the power of negative 1, or negative 1 times 2 to the power of 0. Let's consider like this. Now, please don't forget this 2 we are saying has a power of 1, okay? 2 has a power of 1. Don't say that 2 is just a whole number and it does not have power. Why are we using that law for it? It has a power of 1. Are you following? So 1 over becomes a negative, that is power 1, okay? So now, the other law we're going to be applying here is the power of a power. We have the power of a power here. So we multiply. Negative 1 times negative 1 gives us 1. So times 2 to the power of what? 1. Are you following? Then times 0 index. 2 to the power of 0 gives us what? 1. Okay. So don't forget we're multiplying two numbers like this. We're going to add their power. So we're going to have here, we're going to have 2 to the power of 4 plus 1 times 1. So that's gone. So that will give us 2 to the power of what? 5 as our final answer. Are you following? Or let's evaluate it. 2 to the power of 5 is going to give us 32 as our final answer. Then number 5 said that 3g to the power of 4 all squared to the power of negative 3. So how do we evaluate this? Don't forget we have power of a power of a power in 3 places. We have power of a power. So we're going to be multiplying them together. Are you following? So here we're going to have 3g to the power of 4. 2 times negative 3, that will give us what? Negative 6. Are you following? Yes. Now, here also we have power of a power, but now there's a difference here is that this negative 6 is affecting both 3 and g to the power of 4. So we're going to share the power for the 2 of them. I follow because of this bracket. So here we have 3 to the power of negative 6, then times g to the power of 4 times negative 6. That gives us negative 24. We must share the power individually, okay? So here now we have that equals to 3 to the power of negative 6. Don't forget, negative power, because here now there's nothing we can do. We can't evaluate them. They have different base, they have different powers. There's nothing we can do to them. So we'll just simplify. 3 to the power of negative 6, that will give us 1 over 3 to the power of 6. Don't forget, negative power becomes a fraction. Then times, you can do the same thing also here, 1 over g to the power of 24. Okay, so now that will be equals to 1 to the power 3 to the power of 6 is going to give us 729. So we have 1 over 729 times 1 over g to the power of 24. So final answer will now give us 1 all over 1 times 1 is 1. 729 times this will give us 729 g to the power of 24. As simple as that. So the last question, because of space, we're going to solve it here. Okay, so this is number 6. How do we do this number 6 question? Now, when we look at this, it has a negative power and a fractional power. What can we do here? What we do first is that we try to simplify the bracket if it can be simplified, okay? Now, when you look at this, you might think it cannot be simplified, but it actually can be simplified because I've told us that in the law of indices, we can simplify them when they have either the same base or the same power. So we can simplify it. Now, this one here now, even though the powers are different, the base are different, everything are different, but this power now, we can easily make it a power of 2. We can manipulate and make it a power of 2 so that we can bring them together. What am I saying? We can express a to the power of 4 as saying a squared to the power of 2, b to the power of 2 all over c to the power of 2 negative 1 over 2. Yeah, because 2 times 2 gives us what? 4. Okay, so we can do it this way. Now they have the same power. And don't forget, when they have the same power, we bring them together and let them share one power. We multiply them together and make them share one power. Okay, so here now we're going to have a squared times b, that's a squared b all squared divided by c squared all to the power of negative 1 over 2. Okay, a squared here stands for the base, so a squared times b will give us a squared b, then the same power, we bring them together, c squared. Are you following? Now don't forget that law also deal with division also. We are dividing also and they have the same power. A squared b signify just one single base. Are you following? Just one single base. So this have power of 2. This one also have a power of 2. We can also bring them together. So we can also write this as a squared b all over c all squared negative 1 over 2. They have the same power. So here now, there's nothing we can do again. We have simplified the bracket. The next thing is now this power. Now don't forget, we have the power of a power, right? Power of a power. So we multiply them together. So here we're going to have a squared b all over c. Then we have 2 times negative 1 over 2. Okay, multiply these 2. So 2 cancels 2. So here now we have a squared b all over c all to the power of negative 1. Okay, now, so we are through with this, but what we're going to do here is that we have a negative power. We don't like negative power. We can convert it to a fraction. We can stop here also, but in some cases, they'll prefer fraction. So we can now write this as negative 1 becomes 1 over, okay, a squared b all over c. Are you following? Now, to simplify further, don't forget, we have a number divided by a fraction. Okay, so this denominator multiplies this shortcut. So c times 1 gives us c all over a squared b. Final answer, as simple as that. So now if we can solve these questions confidently, you shouldn't have any problem with any initial questions. Now, don't forget to subscribe to my channel if you haven't. Very, very important as a way of supporting me. And if you have learned something here, share this video. Tell your friends also to watch this video so they can learn more. Okay, tell your friends just to come and watch this so they can learn a lot of mathematical stuff. They can have mathematical insight. Okay, and also don't go like that because practice makes perfect. So you can practice these questions. Yeah, so and let's see what you can do about that. Now, any answer you get, comment there that. Write the answer in the comment section. Type it out, okay? So any of the questions you can solve, just pick any one. If you want to solve everything, you put your answer in the comment section, you include the answer in the comment section and your solution also. And if you can't, you indicate. So I'm going to make videos on how to solve some of these questions you can see right here. So till next time, bye-bye.